Hi, mathletes. Welcome back. We are on day 5 of Matrices, Unit 3. So let's get going. So what does it mean to be invertible? That means, does it have an inverse? Okay. Does it have an inverse to speak of? So that's what we're talking about. Okay. If it is invertible, that means the determinant of A does not equal 0. Okay. So what are your options? No, A is not invertible because the determinant A equals 0. Yes, A is invertible because determinant. So it cannot be B because that doesn't make any sense. Okay. And no, A is not an invertible matrix because the determinant of A equals 0. So it has to be either A or D. Okay. Yes, it's a determinant because it doesn't equal 0. Or no, it's not a determinant because it does equal 0. So the others are kind of contradictory of each other. Okay. If I said, no, I'm not going to the store, that would be confusing. Ugh, it's very confusing as it is. All right. So I'm going to plug this in. So I'm going to go to second matrix, go to edit, click enter, and I'm going to type in these numbers. It's a 2 by 2. Now, once I type in all those answers, once I plug in the matrix, I'm going to go to second, quit. So it's really important just not to watch me do it. It's really important for you to try to do it because it's definitely something that you have to try. So we're going to find the determinant of this and see if it has an inverse or not. So determinant of A, and that equals 0. Okay, so because it equals 0, therefore it is not invertible and it does not have an inverse. Okay, so the answer is A. Now the second one, we're just finding the inverse. So again, please practice along as we go through this. So second matrix, go over to edit, and let's type in these numbers. So 2, 2 is 2 by 2. So 4, enter, 2, enter, 10, enter, and -5, enter. Okay, so we have those matrices in there. Second mode, second quit, and then I'm going to go back in, plug in A, and I'm going to look for the inverse button. The inverse button has that -1 attached. Okay, and those are my answers. Okay, now it looks like they are all fractions, so it's not D, it's not these numbers, so now it's between A and C. So -1/10, or I have 1/8. Okay, well, the first one is not negative. The second one is positive. Okay, this one says -1/4. This says +1/4. So you can translate these to fractions. I wonder if our calculator will do it. Bam, perfect. So if they are into decimals, you go to second math. You go to math. You go to fraction, and bada bing, it changes it for you. So your answer is C. Excellent. Now let's go to the next one. A system of equations can be represented by a coefficient matrix and a constant matrix. So we're putting all the x's and y's into one matrix, and we're going to be solved using the inverse. Okay? So it's going to be A xy equals B. And how we're going to solve that is we're going to be trying to isolate the xy. Well, how do I do that? I need to get this A over to the other side. So that's going to change into xy equals the inverse of A times B. And I'm moving the A over to the other side. All right, coefficients. Coefficients, think of the word coefficient. That means we're talking about the constant, the numbers in front of the variables. Coefficient, it has to be attached to something. So I have A, B, and D, E, part of this one. What are my variables? Well, those variables are X and Y. And that equals what are my constants? My constants are C and F. Okay, and again, how am I going to do that? I'm going to isolate my variables and do the inverse of the coefficient matrix times the constant matrix. So this is one way to solve a system of equations. All right, so let's do it. So solve using the matrix equations using inverses. So again, I'm going to find the inverse of this first one. of the first matrix, the coefficient matrix, and then I'm going to times it by 2, 8. Okay? So that is the plan. So let's do it. So first I'm going to build both of these matrices. So 2 by 2 is already in here. And I'm going to plug in these numbers. Okay, so I have those numbers. Second quit. I'm going to go back in and edit and make my second matrix. This is how many rows? I have 2 rows. And I have 1 column. So I'm going to do 2, 8. Okay, and then second quit. So now if I go back into matrix, I should have 2 of them. Okay, so I'm going to find the inverse of A. So I'm going to type in A to the -1, and then I'm going to multiply that by matrix B. And now I have my answers. So 3, 4. So what does that mean? So if I get 3, 4 as my answer, well, let's look up here. That would mean x, y. So x equals 3 and y equals 4. Okay? All right, let's try that again. So this is my A, this is my B. So I'm going to find the inverse of A and times it by B in order to find out what my values of x and y are. So when I found the inverse of A times B, I got 2, 3. So what does that mean? That x equals 2 and y equals 3. All right, so represent the following systems of equations with matrices, then use the inverses to solve. Okay, so first I need to set it up. So I have my coefficient matrix, I have my x and my y, and then I have my constants. So let's get after it. So the first equation is 3, -5, and 7. The second equation is 2, 1, and 4. So let's set that up, and let's go. All right, so now that we have them set up, we need to put them into the calculator. So we are already ready to go with the matrices. We just have to put in new numbers. So again, we want to go to the edit, click enter, and put in our 2 by 2, our coefficient matrix first. Okay, so I have that in. Second, quit. And then I want to go back into the matrix, go to edit. So once I enter all of them in, second quit, or I think I can even just go back into the matrix. No, I have to do second quit every time. Second quit, so that I know what I'm doing. Now I'm going to go back and do the inverse. So the inverse goes with the first one. Okay, so again, I like to label this A and I label this B because I want to move the A to the other side. Okay, so think about if I had 8x equals y and I wanted to get the x by itself, I would divide both sides by 8. But in a matrix, how do I actually do that? I'm doing the inverse. So again, xy equals, that is not a matrix, Robinson. So A to the -1, again, times the B. So A to the -1 times, I don't know if I even need to have that. Maybe it'll yell at me. Let's see. Let's do an experiment. Do you know what this means? Oh, that looks a little crazy. Let's see if I can second matrix A to the -1 multiply by B. All right, let's do the matrix. Did I edit the second one? Let's see. 2 by 1, 7, 4. I didn't do that one. Let's check the first one. So 3, -5, 2, and 1. All right. Looks good to me. So A to the -1. So we can clear that. We can go to math and make these into a fraction. And then I have 27 over 13. And -2 over 13 is my x and my y. There we go. Okay, so I have so sometimes they're not pretty, and again, you can use that. So I got these decimals. I click the math button, and I can click fraction, and it changes my answers to a fraction. All right, let's set up this one and plug it in. So what's my first equation? So I like to set it up so that I know what I'm working with. Okay, so my coefficients are 10, -9, 7, and 6. I want to make sure my x's are in the same column and my y's are in the same column. So be careful on that one. And then my constants, so what does it equal, are in a row like this. So let's plug it in, find the inverse of the first one, and then times it by the constant matrix, or you can also known as B. All right, for this one, x and y, they both equal 1. So 1, x equals 1, and y equals 1. Okay, so this is definitely a skill where we can't really see the work on paper, so please make sure you're setting up the problems for your teacher so then we know what your thinking is, and then still practice, practice, practice in that calculator, okay? Don't wait for us to do it because then it might be scary later. All right, now we have a bigger matrix, so please make sure when you're setting this up, you have your correct dimensions, okay? So it looks like I have x, y, and z, and I have 3. So this is going to be a 3 by 3. And then this, how many rows do I have? 3 by 1 column, okay? So make sure you're setting this up. So I'll put this in the calculator with you once we set it up. So -3 is my x. I don't have a y for my first one, so I need to put a place value there. So I'm going to put a 0, a 1, and then 9 is the constant. -1, 0, 2. 2 is the constant. 2, -1, 0, and then I have 10 over here, okay? So I have my x, my y, my z columns. I have my constants, and we're going to plug it in, okay? So let's go to second matrix, go to edit, make sure our dimensions are correct. So 3, enter, 3, enter, and let's plug these in. So negative 3, enter, 0, enter, 1, enter. And then I have -1, 0, 2, 2, -1, 0. So before I get out of the matrix, I make sure that my numbers are correct. Everything looks good to go. And then again, second quit, get back in, second matrix, go over to edit. And now this has to be a 3 by 1. So yours should look like what it is up here, okay, right? So I have 3 rows and 1 column. Column, think of columns in Greece, up and down. So I have 9, 2, and 10. Then I exit out, and now I'm going to find the inverse. So second matrix A, inverse button, times second matrix B, and there we go. So I, again, have those lovely decimals, so let's change them to fractions. And there we go. So I have -16/5. I have -82/5. And I have -3/5. So glad we don't have to do these by hand. Phew, that would not be fun. All right, so those are my answers for X, Y, and Z. There we go. All right, thank you for joining me on day 5. On day 6, we're going to just show a different method in solving these. Have a great day, Huskies. Hope you guys are doing well.